Hello everyone, I am Dr. Godandaraman. In this session, we are going to discuss with Fourier transform problem. Look at the problem. Find the Fourier transform of f of x equal to 1 minus x square if modulus of x less than or equal to 1, 0 if modulus of x greater than 1. Hence prove that integration of 0 to infinity sin s minus s cos s by s cube into cos s by 2 ds equal to 3 pi by 16. This is the only we are going to prove. First of all, write the form of Fourier transform. The Fourier transform is nothing but f of s or f of x. Whatever notation we should use, then 1 divided by square root of 2 pi minus infinity to plus infinity f of x e power isx into dx. Now substitute f of x value here and integration with respect to x, we will get the solution. But the problem is f of x given different range. So what's the different range? Look at here. If modulus of x less than or equal to 1 is nothing but minus 1 to plus 1, and then modulus of x greater than 1 is nothing but minus infinity to minus 1, then 1 to infinity. So this range given f of x value. If there is this first range minus 1 to 1 f of x 1 minus x square, and minus infinity to minus 1, 1 to infinity 0, because modulus x nothing but negative and positive both value. Therefore, this value should write the form of 1 by square root of 2 pi minus infinity to minus 1 f of x e power isx into dx plus minus 1 to 1 f of x e power isx into dx plus 1 to infinity f of x e power isx into dx. Now the range split into 3 range. Now what is the f of x value? This f of x value 0 because of minus infinity to minus 1 f of x 0, and this f of x value 0, then this f of x 1 minus x square. Therefore, to substitute 1 by 2 pi square root of this term 0 plus minus 1 to 1 1 minus x square e power isx dx plus 0. Now 1 by square root of 2 pi minus 1 to 1 1 minus x square e power isx into dx. Now integrate with respect to x. Now using Bernoulli function or this term to expand. How to expand this form? E power isx. So 1 by 2 pi square root minus 1 to 1 1 minus x square, this term to expand cos sx plus I sin sx into dx to expand this. Also to multiply this product 1 minus x square into cos x plus I into 1 minus y into, so minus 1 to 1 1 minus x square into cos sx plus I into 1 minus x square sin sx into dx. I just multiply 1 minus x square into cos x plus I sin x. Now look at this, the range or full range. Full range means what? Minus infinity to plus infinity, minus 1 to 1, minus 2 to whatever the range, it's possible to apply with odd function, even function. So what is the odd function, even function? If odd function is nothing but f of x minus f of x, when I substituted x to replace f of to x to f of minus x, minus f of x, then it's a odd function. The odd function is nothing but minus infinity to plus infinity f of x dx, it should be a value 0. The odd function, even function may be, the example is nothing but maybe x, x cube, x power 5, the odd power, and sin x. So these are the odd function, some of the example value. And even function, so even function f of x, when I replace x to minus x, then the value should be f of x, then even function. So even function is nothing but minus infinity to plus infinity f of x dx is equal to 2 times of 0 to infinity f of x dx. For example, here the value possibilities x square, x power 4, x power 6 and so on. Then cos x and then sin x modulus and modulus of x and so on. This is the sum of the variable example for even function. Suppose two function involved. What is a two function? Odd function into odd function, then it's a even function. Odd function into even function is odd function. Then even function into odd function, then even function equal to even function. Just keep in our mind, odd function is minus sign and even function is odd sign, maybe minus into minus, minus into plus, plus into minus, plus into plus. Whatever the rule we apply with this two function when is involved. This formation only we are going to apply with the above condition. So this is the, now here look at here, now the minus infinity to, so when we should apply this odd function even function, minus infinity to plus infinity, minus 1 to plus 1, minus 2 to plus 2 and so on. So for in this function minus 1 to 1 is possible for using odd function or even function. Without apply directly we should follow direct integration also, nothing to worry. But when we apply this concept, it may be possible one term will be removed. So that's only the reason. So now if 1 minus x square, look at here, when x is square, then this is a even function. When the cos function is involved, this is a even function. So even function into even function is nothing but even function. Then this is another term, even function. This is a odd function. Even function into odd function is odd function. So if even function, the full range term is nothing but, how to write the full range? If the even function, we just write the form of f of x 1 by 2 pi square root of this minus 1 to 1, the first term even function, other term odd function. Therefore, if even function 2 times of 0 to 1, 1 minus x square cos sx dx plus odd function 0. Odd function 0. So this is the only we are applied the odd function even function. Now the constant to take out, 2 divided by square root of 2 pi 0 to 1 1 minus x square cos sx into dx. Use the Bernoulli function. So Bernoulli function is nothing but if integration of u v dx equal to u v1 u dash v2 u double dash v3 and so on. Here u dash u double dash u triple dash everything we consider differentiation. Differentiation. v1 v2 v3 are integration. Now I'll take the form, the first one x term, the first one is x term. So therefore u, first differentiation, I mentioned this is a u, I'll take it, and this is a v. So differentiation and then integration. Differentiation, integration. So differentiation u. So u, what is the value u? 1 minus x square. When I differentiate u dash, 1 constant 0 minus x square differentiation 2x. Then u double dash constant 0 minus 2 x differentiation 1. And u triple dash again differentiation, all the values constant, therefore 0 and so on. And then v equal to cos sx, integration of cos sx is sin sx by s, again integration minus cos sx by s square, already 1s is there, the constant when the denominator having s square. Then v3 again integration minus sin sx by s cube. Now use the formula. What is the formula? u v1 minus u dash v2 plus u double dash v3. So u v1 u dash v2, u double dash v3, other terms are 0 because of u triple dash 0, 2 by 2 pi square root. Then when I apply this formulation, 1 minus x square u v1 sin sx by s minus 2x, then minus cos x by s square, then plus minus 2 minus sin sx by s cube. Now the limits is nothing but 0 to 1. When I substituted upper limit, so where to replace the value? 0, where x to replace, right? So now substitute upper limit. Where to substitute upper limit? This places I'm going to substitute upper limit, here upper limit, where x is substitute upper limit, again the lower limit. So upper limit to substitute 1. So this first when I substituted 1 minus 1 0, then minus of minus plus, plus of minus minus, then 2 cos s by s square, then other term plus 2 sin s by s cube. So this is our upper limit. Minus of lower limit, the first term 1 minus 0 sin 0 0. So first term 0, then minus into minus plus, plus into minus minus, 0 into any term 0, then plus sin 0 0. So now we have the value 2 by square root of 2 pi minus 2 cos s by s square plus 2 sin s by s cube. Now take the LCM and then 2 take out, 4 by 2 pi square root of minus cos s by s square plus sin s by s cube. So when I'm taking the LCM is denominator s cube. So divide by s cube. So this term s square. So multiply numerator denominator 1s, s cos s plus sin s. So this is our Fourier transform value. A Fourier transform of f of x is equal to 4 by 2 pi square root of sin s minus s cos s by s cube. If the problem is only Fourier transform, the answer is over. But the question is some integral of, look at the problem, some integration of sin s minus s cos s s cube cos s by 2 ds equal to 3 pi 16. So look at this function. In this function, the Fourier transform, once when we applied the result, no again the integration. If again hence prove that, but the integration is involved the condition, then two possibilities. One is maybe possible to apply with inverse Fourier transform. Another one is Parseval's identity. But when we look at this one Fourier transform, the Fourier transform and then hence deduce that the condition, both the condition Fourier transform when I integrated, so nothing to different function. If any square term, here it's a square term, but the condition is power term, then it's maybe possible is applied Parseval identity. X term to x term, then only possible is applied inverse Fourier transform. Therefore now I'm going to apply with inverse Fourier transform. So we are not integrating, just a simplification. Now apply with the Fourier transform. So inverse Fourier transform formula. The formula is nothing but f of x equal to 1 by 2 pi square root of 1 by 2 pi minus infinity to plus infinity Fourier transform of f of x e power minus isx into ds. Therefore now the range should be minus infinity to plus infinity. To substitute Fourier transform f of x value, 1 by 2 pi square root of minus infinity to plus infinity 4 by 2 pi square root sin s minus s cos s by s cube into this e power minus isx to expand into cos sx minus I sin sx into ds. For in this case, I'm going to apply with, because of the full range. In this full range, x term is here. So should apply to check with the given problem is odd function or even function. And then this function, what is a function? This is a even function, this is a odd function. Therefore, this term is 2 times of the value and this term 0. Therefore, 1 by 2 pi square root into, I'll take 4 by 2 pi out, then 2 times of 0 to infinity sin s minus s cos s by s cube into cos sx minus 0, because of other terms odd function 0. This is a ds. Now to cancel this, so 4 into 2 and the root 2 pi is 2 pi and 8 divided by 2 pi, 0 to infinity sin s s cos s by s cube into cos sx ds. Now the condition, what is the condition? To prove, hence prove that the condition. Now I'm just this right hand side value keep with one side, integration of 0 to infinity sin s s cos s by s cube into cos sx into ds equal to it will be cancelled with what term? 4 times. So when I cancel this 4 by pi, when I just taking with the right hand side, left hand side value is nothing but pi by 4. Therefore pi by 4 f of x, pi by 4 f of x. Now look at the condition. What is the condition? If the Fourier transform, what value should prove? If hence prove that the conditions given. So what is the condition? If integration of 0 to infinity sin s minus s cos s by s cube, cos sx is value cos s by 2. So the value cos s by 2 is nothing but to take this f of x value. So what is the f of x value? F of x equal to, look at here, the starting prove that the condition starting, if this is the only we want to prove. So now look at this, actually up to this we have value 0 to infinity yes we have, and 0 to infinity sin s minus s cos x and divided by s cube. So all the values are there into cos sx, but here what should prove? S by 2. So sx we have, and then the right hand side pi by 4. Now we want to prove this. So therefore now what value? X value. So now the point should take it here when x is 1 by 2, because of the left hand side value s by 2, but we have sx when the value x to replace 1 by 2 should apply here, s equal to 1 by 2. Therefore I am going to take with the value x equal to 1 by 2. So put x value 1 by 2, x equal to 1 by 2. Why I am taking? Because here I want the value s by 2. 0 to infinity sin s s cos s by s cube cos s by 2 into ds, and pi by 4 f of 1 by 2. If f of 1 by 2, what is the f of x value? F of x 1 minus x square. If f of 1 by 2, 1 minus 1 by 4. So when I am taking this 4 minus 1, 3 by 4. F of 1 by 2, 3 by 4. So 1 pi by 4 into 3 by 4. So 3 pi by 16. So what should prove? A sin s s cos s by s cube into cos s by 2 into ds. Now hence proved. So this is the only we are going to show. Hence proved. So this problem we solve finding Fourier transform and finding inverse Fourier transform. Thank you.